In this video, we are going to build a new simulation model. In particular, we will focus on two concepts. The first one is routine in, and the second one is routine out. So, what is routine in? So basically, routine in is the method that we use to define how the work item goes through one activities. All right. And routine out. What is routine out? Routine out is the method that we use to define how the work items leave from the activity. That's it. All right, here we will build a new model based on the model in the previous video. In the previous video, we already built a model for a convenience store with one man till and two self-checkout stations. So previously, we defined customer will arrive at the store every 5 minutes on average, right? All right. And after picking the items they want, they will head to the till to check out. And we have one single queue area here that leads to either a man till or a self-checkout station. If the self-checkout machines are full, customer will queue for the till and vice versa. Briefly put, the customer will go to the available checkout station at a specific time. And we also identify the service time for cashier are triangularly distributed. Minimum 2, most likely 5, and maximum 7 minutes. And we also identify the self-checkout times are 4 minutes per customer on average, right here. In terms of resources, we have two cashier. One work for the day shift and another work for the afternoon shift. We already discussed how we identify the work patterns for each shift. All right. Now, we will focus on the new model. So imagine after a promotional period, customer get to know the store much more before, and they come to the store more frequent. And now customer enter the store every 3 minutes on average. Based on the existing model, we can adjust the property for customer arrival, in particular 3 minutes on average, right? And also, the store has recruited an additional staff member for the afternoon shift. What should we do here? So basically, we can adjust the work patterns for the second shift. In particular, for the afternoon shift, the availability will be 2 steps instead of 1. Click OK here. And another thing I would like you to try is instead of have just one endpoint here to count all the customer throughput from different station, we might have 2 endpoints. One endpoint for the till and the second endpoint for the self-checkout. So we can copy this endpoint. You can press Control and drag it down here. All right. So we have 2 endpoint right now. One for the till, so we have the redundant arrow here deleted. All right. And we don't need these 2 arrow as well. Okay. So right now we have one endpoint for the till, the other endpoint for the self-checkout. Good. Okay. Now, another step we can do is we can identify how we save the output of this simulation. So we can double click on the first endpoint we identify that we save as model 3a.cfv, right? For the menu result. And we can do the same. For this one, we can Identify we want to save the output to model 03b.cfv. Right. So now we are ready to run the model. You can increase the speed and your simulation will run a little bit faster. All right. So right here, you see, we can serve 78 customer at the tilt and we can serve 159 customer as self-checkout machines, right? Great. Now, what's next on the description? Before opening each day, an average of 5 customers are already waiting in the line. And these customers will be prioritized to check out at the main till just because the share machines are not available yet. Okay, we can specify that property by clicking on the queue. And right here, we can specify the start up. So basically, we can tell the computer that we have average 5 customer every day waiting before we open the store. Okay. Right. Now, the managers have introduced a dedicated queue area for the self-checkout machine. Instead of having just one single queue area here, we can replicate it, copy it, press Ctrl, and drag down here. Okay. To make it look more organized, we can change the name of the queue. So let's call this one Q1. And this one will be Q2. All right. So we will have Q1 for the till and Q2 for all the self-checkouts. So there are some errors we need to delete. So for Q1, the customer from Q1 just goes directly to the till. They don't need to go to the self-checkout. We delete it. All right. And for Q2, customer will wait here for the self-checkout machines. They will not go to the till. We delete this error. Good. All right, next on the model description, we know that based on the observational data, 60% of customers prefer using self-checkout. All right, and the remaining 40% choose the main till. So right here, we need to create some routine out decision for customer. Okay, 40% go to the main till and 40% go to the self-checkout. So to do that, we double-click on customer arrival, choose routine out. Okay, right here we already see after the customer arrival, they need to queue for Q1 or Q2. So in this case, we can specify the percent for Q1, which is 40%. Right. And for Q2, that is 60%. Right. And please always remember the total percent here should be 100%. All right, and we can run the model again. So right here we see that the working capacity for the till is around 70%, while the working for each self-checkout is only 40%. So we have some extra capacity within our system. Now, what's next for our model? Within the self-checkout session, 70% of customers use self-checkout 1 because self-checkout 1 will accept both cash and card payments, while 30% will use self-checkout 2, which only allows the card payment. All right. So this is very similar to what we usually see at convenience store or supermarket. So right here, from the source of customer arrival, we have 40% will go to this queue for the till, and we have 60% of them go to Q2 for the self-checkout machines. Now from here, we have 70% will go through self-checkout 1 and 30% go through self-checkout 2. So what do you think? How should we specify the model now? All right, so let me explain it using some graphic notations. All right, so right here we have customer arrival, 40% go to Q1, 60% go to Q2, and we also know that from Q2, we have 70% go to self-checkout 1 because customer can pay by cash or card, while only 30% from Q2 go to self-checkout 2 because they only can pay by card, right? All right, so imagine we have a dummy area here, okay, which is Q2. Instead of specify Q2 literally, we can specify how we route out customer from customer arrival directly to new 2 queues. Okay, so we will route out 70% of 60% of Q2 to a new queue called cash dash card. And we also route out customer arrival 30% of 60% of Q2 to the new queue called card only. Basically, we need to get 42% from the customer pool for cash and card and 18% for the queue card only. All right, let's come back to our simulation model. All right here, let's delete this queue. We don't need it now. We might want to create a new queue, right? So let's call it cash or card. Okay. And if you don't see the title, again, go to graphics and showing title. And we have a new queue here, which is card only, right? And we should have some routing area connected from customer arrival to cash and card, go to self-checkout 1. The same, we also need the connecting arrow from customer arrival, go to card only. And we also need the routing arrow from this queue, go to self-checkout 1, and from this queue, go to self-checkout 2. Good. Now we need to re-specify the customer arrival routing out decision. We can double-click on customer arrival, choose routing out, and now we see there are 3 queues after the customer arrival. So for Q1, remember, 40% of all customer will go through Q1 for self-checkout 1, so we can specify 40%. And for cash and card, we need around 42% of customer will go through this route. And we have 18% of all customer will go through this route. So again, the total percent here should be 100. And where do you get this number? This number is based on your observational data. You need to go to the field, collect the data. Right, we can run the model again. Great. All right, so we already specified the routing our decision from customer go to different queues, go to the till or the self-checkout machines. So now we have new information for the model. Self-checkout machines experience more functions sometimes, requiring the reset at different intervals. Self-checkout 1 will reset every time it serves 30 customer with the reset time of 3 minutes. And self-checkout 2 will reset after serving 60 customer with the reset time of 4 minutes. All right. All right. So we need to specify basically the setup time or the changeover time for each self-checkout here. We can double click on one checkout, go to routing int and choose the changeover tab. So the reset will happen after self-checkout 1 serve 30 customer. So we can specify 30 here. And the reset time is a fixed value, follow fixed distribution with 3 minutes. So we can specify 3 minutes here. All right. And we can do the same for self-checkout 2 machine. Double click here and go to routing int. And we can choose changeover. So self-checkout 2 will reset after every 60 customers. So we can specify 60 customer here with the reset time of 4 minutes, fixed value. Right. All right, so we can run the model again. Okay. Try to observe the performance of self-checkout. So you see we have some change over capacity here. Okay. All right. So let's move on to the next information we have for the model. While self-checkout machines generally operate independently, some customers require assistance to complete their transactions. 90% of self-checkout users complete their payments without issues, while 10% need some help from the staff, and which takes an average of 5 minutes per assisted transaction. Again, let me use some graphical notations to demonstrate this idea. All right. So we have a self-checkout 1 and self-checkout 2, and we have the endpoint where customer will leave the store, right? So after a customer finish on a transaction, they are supposed to go, straight forward to the endpoint. But it's not the case for all customer. Okay, in the real life, sometimes we need some assistance from the staff. Okay, so we need to have a new activity called assistance, right? And we know that 90% of customer will be successful with all their transaction, and they can go straight forward from self-checkouts to the endpoint, where 10% of them will need some assistance, and they need to queue for the assistance before they can go to the endpoint, right? So the staff will not be available to assist all the customer right away. So we need a new queue in front of the assistant activities when we build a simulation model. All right. So again, let's create a new activity called assistant and a queue for it. Okay, let's create new activity here. We call it assistant. Okay, and we know that the step we perform the assistant roughly average of 5 minutes. So the service time still follow the average distribution with 5 minutes. Okay, right. And we also need to create a new queue here. Okay, right. So let's call it queue and show the title. Good. Now it's time for us to connect the arrows from the self-checkout to the endpoint, from the self-checkout to the queue and assistant. So we already have the connecting arrow from the self-checkout to the endpoint, which are good, right? Now we will connect from the self-checkout to the queue and from the queue to the assistant and from the assistant to the endpoint. That is for customer leaving from self-checkout 1. We will do the same for self-checkout 2. Self-checkout 2, go to the queue and go to the assistant stand and go to the endpoint. That's it, right? Good. But we need to specify the routine out decision from self-checkout 1 and self-checkout 2 here. Okay, so based on the model description, we know that 90% of customer will successfully complete the transaction without the issue, and 10% need help. Okay, so on the self-checkout 1, we double click here, go to routine out, and see we have two options for the work item to leave. Okay, so for the endpoint, so we should specify here 90% of the customer. And right here, we have 10%. Those customers from self-checkout 1 go to the queue for assistant. Right? Click OK and do the same for self-checkout 2. Go to routine out and we specify the data that we observe. Okay, 90% of customer will successfully complete the transaction. And this one will be 10% and click OK. All right, there's another step, remember. The store just rerouted a new staff member. Okay, for what? For this assistant. So we need to assign the resources to the assistant. By linking this assistant activity, go to resources, and we can add the resources here is cashiers, right? And click OK, and click OK again. And now we are ready to run the model. Good. All right, remember when we start building this model, we identify how we save the output for this simulation. Now let's check the output a little bit, try to verify if we already correctly build the model as described. All right, so we should go to the location where we save the output. We can use Folder Explorer, and you should go to the folder where you save the output. So in this case, I save Model 3.8 for the TU output and Model 3B for the self-checkout output. All right. All right, very good. So you see, we already serve 130 customers who use the self-checkout. Now, if we look at this output, we will know customer will go through each self-checkout, right? So for instance, customer 1 go to self-checkout 1, customer 5 go to self-checkout 2. Now we can do some small analysis here, okay? So basically, let's filter this column. Okay, now I just want to see all customer go through self-checkout 1. We can untick self-checkout 2. All right, and we can choose all these rows. Okay, so right here we see we have roughly 90 customer go through self-checkout 1. Okay, so we can type something here, 90. Right, how about we want to filter customer go through self-checkout 2. We can untick self-checkout 1 here, tick self-checkout 2. And we can count again. Right? And we see here we have roughly 40 customer go through self-checkout 2. All right? We can take note of that information. So self-checkout 2, we have 40. So total we have 130, right? Let's compute the percentage of all customer going through self-checkout 1. We take 90 divided by 130. And this one as well, 40 divided by 130. So we see this is roughly 70% of customer going through self-checkout 1 and roughly 30% customer going through self-checkout 2, which is exactly what we described the model. Remember, 70% of customer will go through self-checkout 1 because they can either pay by cash or card, but only 30% who will go through self-checkout 2 to pay by card only. Great. Now let's come back to our simulation model. Another step we must do is computing the total processing time and waiting time for each customer. Okay, let's load this Excel file. All right, now we need to use some special label. And to create a label, you can go to data and rules, go to label, add a new label. And in this case, we should type work time, okay? Hey, interesting. The system asking us the label name work time has a special meaning to simulate. Do you want to continue? Okay, so this special label will compute all the processing time in different stage for each customer. We say yes. And let's create a new variable called wait time. Click OK. And the system asking us again if we are sure to create this special label, wait time. This special label will compute all the queuing time for each customer. We say yes. Click OK. And before we check the output, we should run the model one more time. All right, we can check the output, right? The output is here. Great. So we have two new columns. So the work time column again It is only processing time for each customer, and the wait time. The wait time is the queuing time for each customer. So we already finished building the new model using routing in and routing out functions.